All right, so I think this is recording. We're taking a look at, um, I forget, it's skill 8, which skill 8D, they've given us these 6 trig ratios. They've asked us to use our knowledge of the reciprocal relationships, the conversion between degrees and radians to degrees, and also the complementary angle theorem to come up with these ratios. So on these last 6 problems here, let's take a look at them. For the cosine of pi over, or excuse me, cotangent of pi over 3, I look here and it doesn't give me the cotangent of pi over 3. But pi over 3 is the same thing as 60 degrees. Does it give me the cotangent of 60? No. So cotangent and tangent are cofunctions. Um, does it give me the tangent of 30 degrees? Okay. It gives me the cotangent. So I know that cotangent and tangent are reciprocal relationships. So I know that cotangent of pi over 3 is the same thing as 1 over the tangent of pi over 3. I know that pi over 3 in degree measure is 60 degrees, and it tells me that the tangent of 60 degrees is the square root of 3, and if I rationalize that by multiplying by radical 3 over radical 3, I get square root of 3 over 3 as my final answer for number 15. If we look at cosine of pi over 12, I don't see cosine of pi over 12 given, um, but I do see that sine and cosine are cofunctions, and if I take pi over 2 minus pi over 12, then to get a common denominator, multiply that, and I get that 5 pi over 12, and pi over 12 are complementary angles. Sine and cosine are cofunctions. So I've got the sine of pi over 12. But I know that when I convert the sine or excuse me, when I convert 5 pi over 12 to degree measure, when I multiply that 180 over pi, the pi's cancel, and should be 75. Let's take a look real quick on the calculator and double check that and make sure that it is. So if I multiply straight across in my numerators, let the calculator reduce things and do the work for me. Divided by 12. Okay, it's not, I don't even have to convert it. So yeah, I get 75 degrees like I thought. So the sine of 5 pi over 12 is the same as the sine of 75 degrees, and it gives me the sine of 75 degrees as the square root of 6 plus the square root of 2 over 4. All right. So let's secant of 30 degrees. I look through here, they don't give me the secant of 30 degrees. Do they give me the secant of pi over 6? I don't see the secant of pi. In fact, I don't see any secants or cosecants here. So let's use our reciprocal relationship, and that secant of 30 degrees is 1 over the cosine of 30 degrees. I don't see the cosine of 30, but I do see the cosine of pi over 6, and 30 degrees is equivalent to pi over 6 radians. So I have that the cosine of pi over 6 is radical 3 over 2. So division is the same as multiplying by the reciprocal. So this 1 divided by this is the same as 1 times 2 over radical 3. And to rationalize that, multiply that by square root 3 over 3, square root 3 over square root 3, and you get 2 radical 3 over 3, and that's our final answer for the secant of 30 degrees. Like I said before, I don't see any secants or cosecants along here. I know that secant and cosine are reciprocal, so I know that 1 over the cosine of 45 degrees is equivalent to secant of 45. And I don't have the cosine of 45 degrees, but sine and cosine are cofunctions, and 45 degrees is complementary to 45 degrees because they add up to 90, and they are telling me what the sine of 45 degrees is. So if I take the reciprocal of the square root of 2 over 2, I'll get 2 over radical 2. And if you rationalize that, you get 2 radical 2, but in the denominator, that's the square root of 4, which is 2, and 2 divided by 2 is 1. So you get the square root of 2 as the final answer. So the secant of 45 degrees is equivalent to radical 2. For the cosecant of 15 degrees, I don't have any secants or cosecants here. So let's use the reciprocal relationship that 1 over this cosecant and sine are reciprocals. So the cosecant of 15 degrees is the same as 1 divided by the sine of 15. I don't have the sine of 15, but I do have the cosine of 75. That helps me because sine and cosine are cofunctions, and 15 degrees and 75 degrees are complementary because they add up to 90. So I need to take the inverse, or excuse me, take the reciprocal of the square root of 6 minus the square root of 2 over 4. And now this one is a little more work than the others because to rationalize this denominator, I'm going to have to multiply by the number 1, but I'm going to have to use the idea of the conjugate. So I've got the square root of 6 plus the square root of 2. When you multiply a minus b times a plus b, you get a squared minus b squared. When I square radical 6, I just get 6. When I square radical 2, I just get 2. And I have 4 times that. Let's just keep it in factored form for a second because that 4 is going to cancel with that 4 in the denominator. Let's shrink that up and we've got our final answer, right? Because 6 minus 2 is 4 and 4 divided by 4 is 1. So I have the square root of 6 plus the square root of 2. The cosecant of 15 degrees is equal to square root of 6 plus the square root of 2. Alright. The cosine of 60 degrees, I don't see that in radian measure that's pi over 3. Let's make this bigger so I can see it. So let's come in and use our complementary angle theorem. Sine and cosine are cofunctions. 60 degrees and 30 degrees are complementary. I don't see the sine of 30 directly, but I do see the sine of pi over 6. And pi over 6 radians is the same thing as 30 degrees. So the sine of 30 degrees is the same as sine of pi over 6, and they tell me that's 1/2. Alright, so I hope that helps.